So, if you were to guess what is the average chemical engineer, it will be something like this. It's a white male, 42 years old, earning something in between $113,000 per year, working in manufacturing. Does this ring bells? Maybe yes, maybe not. Either way, let's check out some chemical engineering salaries in the USA. Hey, what is up guys? Welcome once again to the channel. It's always great to have you back, and if you're new, don't forget to subscribe. Remember that in this channel we talk about chemical and process engineering for both students and professionals. So don't hesitate and click on that notification bell so you get all my latest videos. Now, I have been asked a lot to do a video on salaries, and actually I launched a poll some weeks ago wondering what will be the interest or the main interest for you guys. Would you like to see salaries review per country, or would you want to see some salary reviews in the world, the comparison or so, or maybe individual salaries or for certain industries or for certain countries? And the one of individual salary reviews for countries was the top decision. So I said to myself, why not start with the USA, which is of course one of the golden standards for chemical engineering. Actually, I would say that maybe it's the place where most chemical engineers and the most pay goes to. So this is a great way to compare directly. If you're in another country or in another industry or another region, you may want to check out the differences and of course make your final judgment. And of course guys, as you can expect, I have a small disclaimer. This is of course not the general truth. These are just statistics, numbers thrown around. I know that there's a lot of anecdotes that you would say that your uncle earns much more, or that your cousin earns way less than the average, or that, I don't know, there's a lot of stories that you can say, but these are just numbers. These are recollected from all the USA. Actually, the interesting part right here is that it is not data from the US Labor and Statistics Bureau. Rather, it's from the US Census, which is kind of different. They are separated, so I don't know, if you're from the US, you will know much more, but essentially these are different data points. Either way, guys, if you want to learn more on how the data is collected and all that, I will be leaving a link in the description so you get to know much more on how they get these data points. Now, let's go directly to the salary review. First things first, the total amount of chemical engineers in the workforce. This may be kind of curious in the sense that there may be people that didn't study for chemical engineering but are acting or working as chemical engineers, and of course people that are actually chemical engineers. The second part will be the average age of the chemical engineers. Now, probably you were wondering, maybe something in between 35 to 45 will be the average. That was my guess initially. When I saw 41, it makes kind of sense. This is a major that has been around a long time already, so there's a lot of people that is older, maybe already retired, and of course there's a lot of people that it's in senior levels, and as you can imagine, a lot of people from young ages, maybe recent graduates or 5 to 10 years experience. And finally, there's a split on the year salaries of the engineers, the average, the male average, and the female average. For now, we will just consider the general average, which is $113,000 US per year. This is before any taxes, so just keep that in mind as well. But now, going directly to the wages, I really love how they have several fields which are kind of similar on the amount they earn per year, and they have financial analysts, computer engineers, or mostly computer hardware engineers. So as you can see, chemical engineering is still on one of the top degrees, is still one of the best degrees to get if you get a job and you stick to it. One little remark I want to make is that the chemical engineer makes almost twice of that of the average person or the average worker in the USA. So definitely something to consider if you are wondering whether or not going to college or not. Well, this is a very quick way to set apart. Well, of course you need to consider debt and all that, but that's another thing for another video. Continuing to wage distribution, which of course is very, very important. Of course, when we are talking about averages, it's kind of tricky because it could be that a very small amount of persons have a very huge amount of salary, and generally speaking, maybe it is skewed towards very small amount of payment for a lot of people, or in the case of chemical engineering, it's kind of, let's say, not that bad. They have this Gini coefficient, which is essentially a measurement on how unequal or how varied are the distribution of the salaries. Now, an important aspect to consider is that in chemical engineering, they have a small value compared to the general, let's say, average in the US, meaning that the distribution of wealth, or let's say salaries, in this case, is very even. And of course, it makes a lot of sense because once you have a degree, well, it's kind of like a very small market if you compare it to the general US market. So chemical engineering pays relatively okay. Maybe you're just a recent graduate, didn't have that much opportunities, maybe you start with a low salary, but rapidly you will get to the, let's say, middle point or the average point, which is something in between $90,000 and $100,000 per year. So a better way to understand this concept of Gini coefficient, let's go to the graph. Okay, now that we are here in the wage distribution graph, we have the wage Gini. The Gini value, remember, the lower it is, more, let's say, equal or better distributed, meaning that the lower amounts and the higher amounts are kind of distributed. As you can see here, let's say that we ignore the top earners, which is something around 7%. But if you were to ignore this, you will see that there's almost a normal distribution curve, and then it skews to the right, which is great because whenever you are talking about wages, what you want to see is that it is much more normal to go to the right-hand side of the average. Remember that the average is something in between 80 to 120. This is actually an interesting topic. I will say that this is very huge because the total amount of engineers that will actually stick into process engineering or to more operating roles that are not that, let's say, valued in the market or more paid will remain in this little section. But at the same time, there's a lot of industries that will pay much more. So I could say that 100 to 130 is still kind of the average, maybe for not so young engineers, but still people that are looking for different type of positions. Unfortunately, we don't have any kind of correlation. This is just raw data. But it's great to see that, okay, maybe you start with something between 50 to 80, which will be the very raw average that I will assume for recent graduates. But as time passes, maybe 5 years, 10 years, you get from 80 to 110. And maybe when you get to your 40 years old, as stated before, the average of 40 years old is something in between here. Maybe you're lucky, you're to the right. Maybe you were unlucky and are to the left. But you get the idea. This 7% is still great in the sense that it's great to know that there's a lot of chemical engineers earning a lot. Because one of the problems, well, not actually a problem, but one of the things that I hear a lot or that I get to that people throws a lot is that chemical engineers are topped in the sense that they will not be able to earn that much as the time passes by compared to another type of job. I don't know, computer science or computer scientist or so. And actually I would say that this is the general rule for any type of employee, or let's say a degree or an employee that actually went to study to the university. If you really want to get paid a lot, you are most likely going to have two options. Either go to a management role or go to C-level. C-level meaning CEO, CFO, CTO, and all these like very important positions in companies. And of course, being a business owner is one of the best ways to get or to set apart from that 200,000 USD mark. Now let's talk about region, or let's say location, geography. Where are the most chemical engineers located and where do they get paid the most? Okay, let's go to the graphic right here, and as you can see, there are many points. Of course, I don't know, I think this is no news. Houston is one of the top places to be. I don't see much California overall, but I do see the Midland right here. And a surprise for me was not to see some data around here, which that kind of makes me think that the data may not be quite complete. So for now, you can assume that this is the hot place, this is another hot place, and hot place. Okay, let's continue to the concentration. Once again, the same. We have a little bit on the Houston area. We have a little bit on the Midland area. We have a little bit on Ohio, Cleveland, something like that. We have a little bit in Indiana and West Virginia. Still willing, for me it's a surprise not to see some data in East Coast. So guys, of course I know that this was not the best interaction with the map, and unfortunately this is the way the data is set. So it's not because they lack of data, essentially those are the main points where they recollect data. Nonetheless, I promise you guys that I will be preparing a video specifically more with the data of the US labor of statistics, so you have more of an understanding on which are the hot places to be in the USA. Now the question arises, which type of industries are the chemical engineers working in? Okay, let's start with the most common, which of course is very important. We're talking about averages, so this is most likely what the average student or the average chemical engineer will end up working on. And we have industrial and miscellaneous chemicals. Of course, you couldn't guess any further. We are working towards creating more chemicals, or maybe in other type of industries, but most likely into creation of chemicals. Second point will be pharma and medicine manufacturing, which is great to hear, especially now with COVID and all that. I think it's nice to hear that chemical engineers are shifting from oil and gas into pharma. Talking of oil and gas, we have right here petroleum refining. I would really love to see oil and gas overall, not just like petroleum refining, because of course there's like petrochemicals, which is right here, resins, synthetic rubbers, fibers, filaments manufacturing. So the way they separate industries is kind of funny, but either way, let's stick to this. Soap, cleaning compounds, cosmetics, manufacturing. Okay, kind of random to put soaps, cleaning compounds, which sounds kind of industrial detergents and all that, versus cosmetic manufacturing, which sounds more like skincare, more like pharmaceuticals. But either way, you have a broad understanding. Mostly is industry, chemicals, oil and gas, pharma, and so on. The least common, and I have a small remark, guys, because I know that there's a lot of people that want to go into the semiconductor industry or work with electronics. And going back to reality, you can see here the least amount of chemical engineers, which is right here, will end up in electronic components or product manufacturing. Aircraft is also something that I always hear some questions that people want to go or have studied aeronautics or aerospace, and they want to see if they can go to chemical engineering, or the reverse, that there are chemical engineers that want to shift to the aerospace industry or maybe to some aerospace materials or so. It is possible, yes, but it is a very small amount of chemical engineers that will be able to do so. Some medical equipment, plastics products manufacturing, which is kind of odd because plastic manufacturing is like huge. I don't know if they have some issue with the interaction between petrochemicals, because it's kind of interesting to see that the top industries is resins, synthetic rubbers, filaments, fibers, which are technically speaking mostly coming from plastic sources. But I don't know, maybe they're talking about mostly plastic for, I don't know. That's a good question to ask. And then we have agricultural chemical manufacturing. So for me, it's kind of interesting to know that there's a huge amount of chemical or agrochemicals being produced, but to be honest, the total amount of engineers that are required are not that much, meaning that most of these processes are automated and they are creating huge amounts of quantities. So if you were to compare the total amount of products generated by an agrochemical engineer, or let's say a chemical engineer working in the agrochemical industry, versus a most generic industry, it will be like totally disparate. And now guys, let's go to the one that you want to hear the most, the highest paid, which are the industries that are more convenient for the chemical engineer. And for my surprise, and at the same time not surprise, is national security, international affairs, anything with military. I will guess that pays great. Now, why is this? Well, essentially because these are very important topics, and mostly these are into defense or government funded projects, so that's why there's a lot of money flowing on. The second part will be miscellaneous petroleum and coal products. So I kind of like the way they use miscellaneous in the sense that it's like very niche applications, I don't know, or random applications. Still, to see petroleum and coal products there seems like oil and gas is still king in the chemical engineering realm. Scientific research and development services. So this is great. Whenever I hear people in the chemical engineering world going or wanting to go to researching or to study a PhD, I always tell them that there's a lot to do there. Unfortunately, sometimes it does not pay great, and sometimes it pays awesome, as you can see from here. Once again, highest petroleum refining, So if you compare, there's a lot of chemical engineers in petroleum refining and it pays the most. So it kind of makes some sense. Pharmaceutical and medicine manufacturing pays also a lot. So if you're wondering, maybe going into pharma or maybe going into oil and gas is still safe bet for the chemical engineer. Now the lowest paying, as stated before, agricultural chemical manufacturing engineering, most likely because you don't require that much chemical engineers, and well, this kind of makes contradictory in the sense that it makes a niche application for certain engineers that may or not know how to operate with agrochemicals, but at the same time it may not be that difficult. Tire manufacturing for me is of course a very niche application, kind of hard to make a decision on that. Plastic product manufacturing, this is for sure pretty straightforward. I think that there is not so much science in plastic. Of course there's, don't get me wrong guys, but there's a lot of young engineers going to plastic production. So one thing is say that there's a lot of chemical engineers going to plastic production, which is the one I was guessing why was it low. But on the other hand, I know that this is not the best paid jobs. So if you want to get into better paying jobs, go to something more broad like oil and gas, maybe refining, maybe going to pharma. Activities for mining, of course, that's a very raw material thing to do. Electronic component. So this is actually something I'm not on board. So the semiconductor industries pay quite well. So I'm not quite sure why they get this data. Maybe they are adding some other industries which lower the average, but something to consider guys. Don't think this is 100% real. And still talking about industries, we have a little topic on industries by share. So let's check it out. So remember that we have the workforce of 75K chemical engineers. This is a huge growth, 18% growth. This is definitely huge growth of chemical engineers. So as you can see, there's a 4% increase in chemical engineering jobs, and you have a 18% of chemical engineers. So it kind of makes a little bit chaos. So that's why we have problems with the job market. Nonetheless, let's go back to the graph. We have most of the people in industrial and miscellaneous, pharmaceuticals, petroleum. So all the yellow ones that you see right here, guys, are industrial, manufacturing ones. Then we have this part right here, which I would say are kind of service, professional, scientific, and management. Okay. Then we have a very small amount of agrochemicals, and finally public administration, which is the defense part or the military part. Now we need to talk about diversity, which I know it's a hot topic in the US, well, mostly in the world, but in the US is something very relevant to talk about. All the wage disparities on races, gender, and all this is very important to address. So let's give it a look. We have 61,000 chemical engineers, which are male. Then we have almost 15,000 chemical engineers, which are female. The ratio is almost 1 to 5, 1 to 4. This is a very common ratio. I have it in my YouTube channel. I know that chemical engineering universities may have something in between. Some countries I've heard that have more chemical engineering students from the female gender, which is great. But I would say that generally speaking, engineerings are male dominated. Okay, so what we have here, essentially, orange ones are chemical engineers, gray ones are the average. So as you can see, a lot of white people going into chemical engineering, that's normal, above the average, which is something that you will expect. Most white Americans have access to education, or it's easier compared to other. Then we continue with the Asian American, which is by far way much more educated. So a lot of chemical engineers from Asian descent are willing to focus their attention into bachelor degrees. Needless to say, guys, this is not a race, war, or fight or so. I don't want to make any kind of chaos or problem. But from statistically speaking, Asians have it better because they are almost twice the ratio. You compare white versus the general white employee, well, Asians are way better. And then something, unfortunately, which is the black community has a smaller amount of chemical engineers, not only in amount but also in percentage, meaning that there's a lot of black people working in the workforce of the US, but not many are achieving the chemical engineering status. Then we have other 2 or more races, American Indian, Native, Hawaiian, all these little smaller minorities, which unfortunately we don't have that much data to talk about, so I'll just skip it. Now let's talk about gender and age. The average for males is 42 years and the average for female is 36 years old. So why this is a huge difference? I would say that most female are going to quit chemical engineering for their families. That would be my best guess, not quite sure. And well, let's go and check out this graph. Let's check out the graph. So as you can see here, this is a little boom. Chemical engineers at their 26, that would be something like 5 years ago, no, 3 years ago. Then we have a huge boom of chemical engineering, which is at 38 years old. So I'm pretty sure that between 40 and 38, that's something around 15 years ago. That would be 2005. So that would imply that you're making the decision at the millennium. Yeah. So back in 2001, 2002, chemical engineering was hot as it was. It doesn't make that much sense to me because I will guess that a lot of the engineers will be going for computer science or so. I don't know what happened in the millennium. Maybe because of the oil and gas wars and all that, there's a lot of manufacturing going from the Middle East to America. That could be one reason on why then it boomed and a lot of people started to go to the industry. I don't know, it's a very broad guess, but this is what the data states. There's also a little boom 46 years old. Well, not that much, but I would say that this is the most relevant one. Then comes education, which as you can expect, guys, in order to become a chemical engineer, you must study chemical engineering. And here it is. Actually, 86% of the chemical engineers or people that are working in chemical engineering roles studied engineering. So they can be material engineers, they can be biotech engineers, they can be mechanical engineers, whatever type of engineering, but they are still engineers. Now the interesting part will be this little section, which is 14%. So there's a lot of physical science, or people that studied physical science, such as chemistry maybe, such as biology, maybe even physics. Those are like very small applications. It's very small amount of people that can make the shift from chemist to chemical engineer. Oh, by the way, ignore biology. We have a unique place for biology. Business, so this is also a very interesting one. A lot of people go and study for business and they end up working in chemical engineering roles, either as C-level people or maybe they are actually doing some sales, technical sales, that you are not quite required to be an engineer, but you still are working in the chemical engineering industry. This is one of the best sections I found from the report, and actually it's not quite related to the skill set of chemical engineers or to the salary, guys, but it's something worth checking out. Actually, I will be preparing a video on type of skills, soft skills, hard skills for chemical engineers, so don't make that much attention to this part. But overall, what people is looking is science, math, critical thinking, active learning, operation analysis, judgment decisions, system evaluations, service orientation, programming, and much more. And finally, guys, let's check out the projections, what is expected in the next 5 to 10 years. Now, going to the graph, we see that the average, the national average, is kind of growing. So very optimistic for the general average. And the chemical engineer, this drop is the classical drop I've seen lately. I see that chemical engineering has been going through rough patches. But for now, you can see that maybe from 2026, maybe the recession will help, or recovery of the recession will help, and eventually it will be great all the way to 2028. So apparently this is kind of cyclical. So people leave chemical engineering, the chemical engineering market is relieved, then there's a lot of job opportunities, a lot of people go back to chemical engineering, and then the cycle repeats. So guys, thank you for joining me. I know this was a longer video than expected, but definitely it has some valuable content, especially if you're in the US or maybe you want to compare your salaries. This is something that I wanted to do a long time ago. Some surprises I saw is of course the white to non-white distribution. There's a lot of white chemical engineers versus non-white chemical engineers. Also, didn't surprise me, I already know, but it's something that needs to be talked about, is the ratio between male and female. Another thing that surprised me and at the same time wasn't that of a surprise is how the cycle goes up and down, up and down. But still, chemical engineering, it may be a cycle but going upwards, which is the important part. As long as there are requirements for chemicals to be produced, there will be requirement for chemical engineers overall. Now, of course, the job market is something to talk about, but in general, chemical engineers are required in our society. Now, guys, what do you think about the report? Is it okay, or maybe some confusing data, maybe incorrect data, or do you have some other type of data or set points that we can compare? Let me know in the comments. I'm more than looking forward to discuss them. But for now, guys, this is all on my behalf. I'll see you in the next